So, our topic for today is kinematics. In kinematics, in this topic, today we will be discussing uniform motion. Uniform motion. Now, in uniform motion, first of all, we should know what is mechanics. Mechanics is basically a branch of physics which deals with the study of motion of material objects, that is called mechanics. So, that is mechanics, which deals with the study of motion of material objects. Now, again, mechanics is classified into three: statics, kinematics and dynamics. So, first of all, statics. Now, as the name suggests, statics means when the object are at rest, means they are not moving. So, if an object is at rest, that doesn't mean there is no force acting on it. There are forces which are acting on it, but you can say they are in equilibrium. That means they are cancelling out the effect of each other, and hence the total force on the object is 0. So, you can say static is the branch of mechanics which deals with the study of motion of objects under the effect of forces which are in equilibrium. Okay. So, now second is kinematics. Now, it is that branch of mechanics which deals with the study of motion of objects, like without taking into account the factors which causes the motion. For example, the nature of force, the nature of bodies, etc. So, this is known as the kinematics, means the branch of mechanics which deals with the study of motion of objects. Then comes third is actually dynamics. Dynamics is the branch of mechanics which deals with the study of motion of objects taking into account the factors which causes motion. So, the difference should be clear. Kinematics is a study of motion without taking into account the factors, but this is a study of motion of objects in which we take into account the factors which causes motion. Now, we are dealing with objects in motion. So, now object in motion, how to define a rest? See, a body is said to be at rest when its position with respect to the surrounding is not changing. An object is said to be at rest if it does not change the position with time with respect to its surrounding. Then the body is said to be at rest. For example, you can say even like this book only, which is lying on the table. So, this is at rest for the person who is sitting next to it, for me, for you and everyone. Then comes the motion. Now, again, motion is what? An object is said to be in motion if it changes its position with time with respect to the surrounding. Like when it is respect to the surrounding, it changes the position with respect to it changes its position with time with respect to the surrounding. There are many examples of motion like a moving train, a car which is moving, running kid, running man walking on the road. These are examples of rest and motion. Now, see, rest and motion are just relative. Now, rest and motion are relative. There is no term which is called absolute rest or absolute motion. Now, for example, see, an object can be at rest in one situation, but in other situation, the same object can be in motion. For example, if a person sitting in a moving train is at rest with respect to his fellow passenger, but in motion, the respect to the object but is in motion with respect to the person who is standing outside the train. So, these are what? These are just the relative things, means rest and motion. There is no absolute rest, no absolute motion. Even in case of rest, when I gave you the example of this book which is lying on the table. Now, this book might be at rest for all the person who are on the earth, but consider the person who is on the moon. For him, this book is at motion. So, rest and motion are the relative terms. They are not, there is no such thing which is called absolute rest or absolute motion. That depends upon the frame of reference, which we will be discussing further. Now, types of motion of a body. Now, There are mainly two types of motion. First of all, the rectilinear motion. Now, rectilinear motion is that motion in which a particle or a point mass is moving along a straight line. A particle or a point mass is moving along a straight line. Then comes the translatory motion. Now, in translatory motion, in which a body which is not a point mass is moving such that, not a point mass means it is a big mass, is moving such that it's all the constituent particles moves simultaneously along the parallel straight lines and are shifted through equal distances in a given interval of time. So, that is a translatory motion. Basically, these both are what? These both are straight line motion. Rectilinear motion is for the point mass, this is for a big mass body. Now, rectilinear or translatory motion can be a uniform or a non-uniform motion. Next is the circulatory or oscillatory motion. Okay. So, now we have circular or rotatory motion. So, first is circular motion. Now, circular motion is that motion in which, see, we are considering a point mass or a particle. So, circular motion is that motion in which a particle or a point mass body is moving on a circle. That is circular motion. Now, in case of a rotatory motion, now, rotatory motion is that motion in which a body which is not a point mass body is moving in such a way such that all its constituent particles move simultaneously along the concentric circles whose center lies on a line called the axis of rotation and shift through equal angle in a given time. Basically, circular motion is for the point mass and rotatory motion is for actually the body which is big one, it is not a point mass. Now, we have oscillatory or vibratory motion. Now, oscillatory motion, oscillatory motion. Now, in an oscillatory motion is that motion in which a body moves to and fro and back and forth repeatedly about a fixed point, and that fixed point is actually called the mean position. Now, in a definite interval of time. Now, in such a motion, the body is confined within well defined limits. They are known as the extreme positions and the mean position on either side of the mean position. So, basically it is well defined. On either side of its mean position, the maximum distance from mean position is extreme position, and this is also known as the amplitude. On either side of mean position, it means a periodic or a bounded motion of a body about a fixed point is called an oscillatory motion. That is the motion of a, you can take an example of a pendulum, the motion of a pendulum or a wall clock. Now, that is an oscillatory motion. So, basically it is to and fro, back and forth motion repeatedly about a fixed point, that is an oscillatory motion. Now, if in oscillatory motion the amplitude is very small, okay, if the amplitude is very small, that is microscopic, that is small only, the motion of the body is said to be, now this is vibratory motion, that is known as vibratory motion. So, basically in vibratory motion it is an oscillatory motion only, but the amplitude or the vibration is very small. Now, as we have talked about the point mass, so let us discuss is the what is the point mass, or what is the concept of a point mass object. Now, an object can be considered as a point object if during motion in a given time it covers a distance much greater than its own size. Okay, so means it is covering a lots of distance than its own size. For example, just take a simple example that a car traveling a few hundred kilometer distance can be taken as a point object, because now suppose it travels 100 kilometer. Now the point of car, sorry, the size of car is very small as compared to the distance 100 kilometer. So that's a point object. Now if you consider a car traveling a distance which is not very large as compared to the size of car, then the car cannot be taken as a point object. So basically we can take point object only when the distance covered by that object is much greater than the object itself. That is called the point mass object. So now the frame of reference. Now frame of reference. Now see, we have already discussed the frame of reference when we were discussing their absolute rest and motion. So basically what is a frame of reference? Now to define it, the frame of reference is actually attached to an observer with respect to which the observer can describe position, displacement, velocity, acceleration and etc. of a body. For example, see now when we were taking that example of a train, so now there were two observers. The one for his fellow observer, that person was at rest. So basically for that fellow observer, the frame of reference is the train. So according to him, all the persons who is sitting inside the train will be at rest, but the person who is on the earth, who is on the ground, or you can say platform, so that for him the frame of reference is the earth. So basically all the person on the train for him is moving. So now this is what the frame of reference. For one, the frame of reference is train, and for other, the frame of reference is the earth. Similarly, when I was giving an example of the book, the frame of reference, the book is at rest. The frame of reference, like all the people who are on the earth, the frame of reference is earth, the book is at rest. But one who is on the moon, the frame of reference is the moon. For him, the object is moving. Now, and the frame of reference can be also of two types: inertial frame of reference, non-inertial frame of reference. We just have to know in this that inertial frame of reference is that in which Newton's laws of motion holds good. Non-inertial frame of reference is when Newton's laws of motion does not holds good. That's about frame of reference. Now, motion in 1, 2 and 3 dimension. First of all, what is one dimensional motion? One dimensional motion. Now, the motion of an object is said to be one dimensional motion if only one of the three coordinates specified by the position of an object changes with respect to time. See, basically there are three coordinates in which we describe x, y and z, the position x, y, z. So, one dimensional motion is actually a straight line motion in which the object is moving in a straight line in a well defined path. So, only if one of the coordinates is changing, like either x is changing or y is changing or only z is changing, then we say that it is the one dimensional motion. Now, the example of one dimensional motion is the motion of a train along a straight railway track, an object dropped from a certain height above the ground. So, this is an example of one dimensional motion. Now, what is two dimensional motion? See, in two dimensional motion, if any two coordinates, either x, y, y, z or x, z are changing. So, to define it, the motion of an object is said to be two dimensional if two out of three coordinates specifying the position of an object changes with time. In such a motion, for example, the motion on a plane. Plane means a level ground. For example, an insect crawling on the floor. You can also take earth revolving around the sun and a billiard ball moving over the billiard table. So, this is a two dimensional motion. Now, the three dimensional motion. Three dimensional motion. In three-dimensional motion, like of all the three coordinates are required to specify the position of an object. So, to define it, the motion of an object is said to be three-dimensional motion if all three coordinates specifying the pattern of the object changes with respect to time. Such a motion of an object, for example, when an object moves in a space, for example, a kite flying, flying of an aeroplane, the random motion of a gas molecule, bird flying. So, when all of the three coordinates are required for its change, that is known as the three-dimensional motion. Okay. Now, see, there are two types of quantities known as scalars and vectors. So, our first topic is the scalar quantities. Scalar quantities. A physical quantity which have only magnitude, or we can say that a physical quantity which can be described or only by the magnitude and doesn't need any direction, they are called scalar quantities. For example, if I ask someone the mass and he says the mass is 10 kg, so it doesn't require any direction. So, mass, length, time, distance covered and the speed, temperature, work, etc. are few examples of scalar. And the scalar quantities can be subtracted, multiplied or divided by the ordinary law of algebra. Now comes the vector quantities. Now, second is the vector quantity. Now, vector quantities, in addition to scalar, they need a direction to completely specify it. The physical quantity which have magnitude as well as direction, they are called vector quantities or vectors. Displacement, velocity, acceleration, force, torque, gravitational intensity, etc. These are all examples of vectors. Now, see, scalars can be added algebraically, but vectors cannot be added algebraically. They need spatial laws known as vector law of algebra, which we will be discussing in our next chapters. Now, see, how to represent a vector. A vector is basically represented like this. This is an arrow. Now, this represents a vector. Now, you can say this is a vector, suppose A, okay, in which its length, the length of the vector gives you the magnitude, and this arrowhead, this gives you the direction. Now, see, the initial or starting point is known as arrowhead. This is known as the tail or the origin of vector, and this is known as the tip, which tells the direction. So, the length gives the magnitude, the arrowhead gives the direction. For example, if I draw a vector like this, now this is same as this vector, but the length is twice. Since they have same direction, but its magnitude is twice of it. So, as we can say, suppose this represents 5 meter per second velocity, so this will represent 10 meter per second velocity. Now, both are same. Why? Because they are in the same direction, but the magnitude of this is twice of this. So, the length of this will be twice of this length. Okay. Moving to the next part. Now, see, distance. Distance, or this is also known as the total path length. So, distance. Now, distance, or you can say the total path length. See, distance is a scalar quantity. So, we will algebraically add it. The total path length of an object during motion in a given time is the length of actual path traversed by the object in the given time. Now, you consider the object which covered 3 meter in this direction, and then consider this as 4 meter in this direction. So, now the total path length, you can take this as A, B, C. Total path length is 3 plus 7. So, distance travelled will be 7 meter. Okay. Now, talking about the displacement. Now, displacement, now if we want to calculate the displacement of an object in a given time interval of time, now write displacement. Okay. Now, the displacement of an object in a given interval of time is defined as the shortest distance between the two positions of an object in a particular direction during the time, and is given by the vector drawn from the initial position to the final position. So, displacement, to get the displacement, now this is the displacement. So, if you solve it by using Pythagoras theorem, this comes out to be 5 meter. So, displacement is what? The difference between the initial and the final position. This is the displacement. The displacement will be 5 meter. Now, consider the object is travelled from A to B, then B to C, then from C to A, means it is back to A. Now, what is the distance in this case? The distance is, you simply add all of them, 3 plus 4 plus 5. So, that is 3 plus 4 7 plus 5 12 meter. But what will be the displacement? Now, displacement will be zero. This is because now the object has returned back to its initial position. So, now the displacement will be 0. Now, why 0? Because the object has returned back to its starting point. So, basically what is the difference between initial and final position? Is 0, because the object is now back to its starting point. So, the total path length of the distance is a scalar quantity. Its value can never be 0 or negative during the motion of an object, whereas in case of a displacement, that could be 0 as well as negative also in the motion. Now, our next topic is speed. Now, we all know, as we have discussed, the speed. Speed of an object, first of all I should tell you, speed is a scalar quantity. Now, speed of an object in motion is defined as the ratio of the total path length covered and the corresponding time taken by the object. So, basically speed is total path length upon the time taken. As we have discussed in our smaller classes, although speed is distance by time. The speed is a scalar quantity. It gives no idea about the direction of motion of object. The speed of an object can be 0 or positive, but it cannot be negative. So, that is the speed. Now, here comes the uniform speed. Now, what is the uniform speed? The uniform speed, an object is said to be moving with a uniform speed. Object is said to be moving with a uniform speed if it covers equal distances in equal interval of time. Now, just remember, equal distances in equal interval of time, however small these time interval may be. So, this is known as the uniform speed. Now, variable speed. Variable speed is, an object is said to be moving with a variable speed if it covers equal distances in unequal interval of time, or unequal distances in equal interval of time. That is the variable speed, howsoever small these intervals may be. So, that is the variable speed. Now, let us come to our last topic, not last, means the, sorry, I can just cut all this. Now, start. Average speed. Now, average speed is basically the total distance. Here you should know that is the total distance upon the total time taken. That is the average speed, the total distance upon total time taken. This is known as the average speed. Now, instantaneous speed. Instantaneous speed. Instantaneous speed. Now, when the speed of an object is variable, then the object possesses different speed at different instant. The speed of an object at a given instant of time is called the instantaneous speed. Now, that is known as the speed. Now, just remember the speed at a given instant of time, that is known as the instantaneous speed of an object. Now, instantaneous speed of an object at an instant of a time is defined as the limit of average speed as a time interval that delta t becomes infinitesimally small, which is actually very small. So, to write this instantaneous speed, actually this is equals to, you take limit delta t tends to 0, okay, which is delta s by delta t, okay. So, that is the instantaneous speed, because in this time interval is very small, delta t tends to 0, delta s by delta t, or you can write this as ds by dt, where ds by dt is a differential coefficient of x with respect to t, or you can also say that it is the first derivative of distance with respect to time, in which, like in calculus we say. Now, in case of uniform motion of an object, the instantaneous speed will be equals to the instantaneous speed will be equals to its average speed only in case of uniform speed. So, this is the instantaneous speed in which you will take limit delta t tends to 0, delta s by delta t, or directly ds by dt. The next topic, velocity. Now, velocity of an object in motion. Now, first of all, you should know this is a vector quantity. Vector quantity. The velocity of an object in motion is defined as the ratio of displacement and the corresponding time interval taken by the object. Since speed was distance by time, so velocity is what? Velocity is actually displacement by time. Displacement by time. This is velocity. So, this is velocity is displacement by time. Okay. So, velocity is a vector quantity. Now, again in terms like the speed, we have uniform velocity as uniform speed, non-uniform speed or variable speed, we have uniform velocity, non-uniform velocity or variable velocity. Now, variable velocity, an object moving with a uniform velocity, an object moving with a uniform velocity, if it undergoes equal displacement, in equal interval of time, howsoever small these intervals may be. Now, variable velocity. Now, an object is moving with a variable velocity if it undergoes equal displacement in unequal interval of times or unequal displacement in equal interval of time, or there is one more condition since the vector quantity, or changes direction of motion while moving with a constant speed. See, even if the speed is constant and the direction is changing, there is a change in velocity, because velocity is a vector quantity. Whether you change its magnitude or direction, the velocity will change. So, that is the variable velocity. Now, the average velocity. Now, average velocity is basically for a given motion of an object, the average velocity is that uniform velocity at which the object will cover the same displacement in a given interval of time as it does with the actual variable velocity during the given interval of time. Or by simple formula, average velocity is what? You take the net displacement upon the time taken. So, average velocity is total displacement or net displacement upon time taken. Now, again we have, as we have the instantaneous speed, we have instantaneous velocity. Now, instantaneous velocity. Instantaneous velocity. Now, the instantaneous velocity of an object at an instant of time is defined as the limit of the average velocity as the time interval delta t becomes infinitesimally small or very small, like very small. So, if you see instantaneous velocity, yeah, average velocity displacement by time taken, so we can write velocity, it's a vector quantity, average, that is equals to delta x by delta t, where delta x represent displacement upon time taken. So, in instantaneous velocity, we take v, we write t for that particular instant, or not t, just write I, because it is an instantaneous velocity. So, this is limit delta t tends to 0, delta x by delta t, which is equals to dx by dt. Dx by dt. So, see, I am putting this sign because this is displacement, which is a vector quantity. Okay. Though the instantaneous velocity of an object at a given instance is the first derivative of displacement with respect to the time at that instance. So, v instantaneous is dx by dt. Okay. Now, we will be discussing some graphs. Okay. Now, we will be discussing some graphs. So, the first is position time graph. Now, taking time on the x axis and position on the y axis. Now, the position time graph. Now, see, if you consider the motion, like you consider this as a point AB. So, you can say consider this motion as AB. Now, from the graph, as you clearly see, though the time is passing, but the position of the object is not changing. So, that means the object is at rest. So, this graph, the object is at rest. Now, consider the same graph only, but if you draw a line, suppose inclined to time axis. Now, I am drawing a line inclined to time axis. Okay. So, this is the time and this is displacement. Now, you can see from the graph, as the time is increasing, the displacement is also increasing. So, this represents the graph of uniform motion. This is what the object is covering a constant motion or uniform motion. Okay. This is of uniform motion. Now, also suppose if we find the slope of this graph. See, basically to get the slope of this graph, you will get to know the slope further in further videos also. So, for the time being, slope is basically the y intercept upon the x intercept. So, if you do the y intercept upon x intercepts, this will give you the velocity. So, the slope of displacement time graph, you should know this, the slope of displacement time graph, slope is also known as gradient. The slope of displacement time graph or the gradient, that gives you the velocity. Now, one more point, steeper the slope, more is the velocity. Now, you consider this as the velocity VA and consider this as the velocity VB. Now, since VB is more steeper than VA, so this VB is greater than VA. That means the velocity of object B is more than the velocity of object A. since this has more steeper slope. Now consider one more thing. Consider this as velocity c. Now as we can see, though object c is starting with some velocity, with some initial velocity like time t equal to 0. Time t equal to 0 means when we are observing, not when the initial velocity is 0. So we can see that Vb is equals to Vc. Why? Because they have same slope. So the slope of displacement time graph, slope of displacement time graph or the gradient, that gives you the velocity. And how to find the slope? You do y-intercept by x-intercept. Okay. So moving on to our next graph is the velocity time graph. Now again consider the same thing like AB. Now AB represents the object moving with the uniform velocity, because here suppose V naught has some value, take it to be 40 meter per second. So that means the object is moving at 40 meter per second as the time is passed. So it means the velocity of object is 40 meter per second. So that is for the uniform velocity. Now this represents, now see, this is an accelerated motion. Why? Because as the time is increasing steadily, the velocity is also increasing. So this is what? An accelerated motion. And also, how to get an accelerated motion? See, you draw it like this, you find the slope of this graph. So the slope of this graph will give you the acceleration. So you should know that the slope, the slope of velocity time graph or the gradient, the slope of velocity time graph or gradient, that gives you the acceleration. That gives you the acceleration. So the slope of Vt graph or the gradient of the Vt graph, that gives you the acceleration. Now suppose we have to find the displacement. Now from A to B, we have to find the displacement, let it be time t1 and this as t2. Let this be t1 and t2. Now to find the displacement, we find the area under this graph. So this is what? A rectangle. This will give you L, or you can take it as square also. This is this side times this side. How much time interval and how much velocity. Similarly for this, if you want to find the displacement or the distance covered from time 0 to t, what do we have to do? We have to find the area under this graph. Now this makes a triangle. So using the formula of half, this is base into height, half into base into height, that will give you the displacement. So one more point, that is the area under velocity time graph, that gives you displacement.